But yet, quantum mechanics is still flawed. And Professor Goldstein is one of the great mavericks. He believed that it's also flawed, but I think for different reasons. Because quantum mechanics is based on differential equations. And for example, Schrödinger equation is differential equation. That is part of calculus. And calculus tacitly assumes that you have a continuum. And all these ancient Greek people, a very smart guy called Zeno, pointed out that you cannot reason. So Zeno was a sophist, and let me recall his paradox. He has several, one of them with Achilles and the tortoise, but the easiest way is the halfway paradox. I can prove to you that if I walk from here to the blackboard, I never ever make it, because first I have to go halfway, then I have something left, then I have to go halfway, then halfway, and halfway, and halfway, and no matter how many times I do, I never make it, because I have to go halfway. And the usual resolution in calculus is you have an infinite series, you add up so-called infinitely many numbers, and it converges. So I say sometimes when you add up infinitely many numbers, you can get a finite number. This is a stupid explanation. A much better explanation is the assumption that you can always go, there's a distance, always divide this in half, is wrong. Sooner or later, we know, and it is in physics, the atom or the quark or whatever is not, the Planck distance is not, you cannot indivisible. But mathematically and conceptually, people think that you can do it. Eventually, you cannot divide it. So in my philosophy of calculus, what I call discrete calculus, the real numbers are not real. It's an oxymoron. It's a consistent terms, real numbers. Like many things, okay? Like justice, the time of justice is not always just, at least in the past and also even today. So, real numbers are not really real. They are fictional. So, the idea that you can, that all the numbers exist. For example, what I taught in this very room, the intermediate value theorem. If you have a function, continuous function, and it's positive here, and it's negative here, and A and B, there exists a place when it crosses the x-axis. Baloney! 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 No! No, no, no! Some of them do! Y equals x! Sorry. That's cross the real, my real axis. But the curve y equals x squared minus 2, that's not. So, if you cut it, it looks like it does. Because to the naked eye, it looks like it's crossing. So if your y equals x squared minus 2, plot it, and so parabola. Right here, the graphical solution. If you use algebra, you get that it crosses x squared with 2. But this number does not exist. It had been shown 2,500 years ago. There was a big crisis. And that's why it's called, as a euphemism, irrational. But most mathematicians, even maybe Professor Goldstein, do believe that this number doesn't exist. But in my philosophy, I am a neo-Pythagorean. I believe that the proof that the square root of 2 cannot be written as a fraction of two integers. Does not show that the square root of 2 is irrational number. It shows that the square root of 2 does not exist. It does exist as a symbol. There's no longer yet dividing in the square root of 2. Like infinity exists as a symbol. But it's only a symbol. To you, the fancy philosophical world, it does not have ontological existence. It's completely fictional. And the proof that many of you know that it's currently written, that's proof it doesn't exist. When you look at the picture, it looks continuous. If you have a good, high quality, high resolution, it looks very, very continuous. But if you understand what's going on, it's all discrete. You have pixels. So if the pixel size is small, it looks continuous, but nevertheless, if you know, it's really discrete. Same thing with a movie. A good movie looks continuous, but it's really a discrete collection of frames. So the digital computer is digital. So in my philosophy, the universe is a big computer. I call it the big computer in the sky. It's much, 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 much bigger than any computer you can think of. But nevertheless, it's finite, and its pixel size is also very, 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 very small. But still finite. Since it's so tiny, we'll never be able to write it down. So I have a symbol for it. H, like Planck's constant in physics, the mass size. In numerical analysis, when you do approximations, you have an approximation using a mass size. And the other number, the biggest number exists. And I call it, being very humble, Z. So Z is the biggest number. And it's not infinity. I cannot write it down. It's so big. I cannot write it down. But I do know. And now I used to think that Z plus 1 equals 0. Like a planet when you go around. So eventually you go back to 0. So any numbers between 0 over 2 and Z are the negative numbers. But now, maybe it's possible that it's not. That it's really an interval, minus Z to Z. And if you do Z plus 1 in the big computer in the sky, you don't have an answer. You get an error message, an overflow error in the big computer in the sky. Now, 1 over 0 is undefined, or you can say it's undefined. So here's an identity, H equals 1 over Z. Now, even if you don't believe in this discrete version, here is a proposal for calculus reform. It's so hard. I struggle, students, many of them, even people who get A's, really don't understand what's going on in continuous world. And I don't blame them, because it's so artificial, it's so unnatural, all this calculus that was invented by Newton and made rigorous, quote-unquote, in the 19th century by Cauchy and by Astras, and now still going strong with analysis. You can develop from scratch a whole calculus, and that independent whether you believe in the big computer in the sky. You can still believe in infinity, but for pedagogical reasons, if you want to have more scientists and engineers and will not be turned off and transferred to political science, even then you may consider teaching calculus my way. So let me tell you how to do it my way. In this very room, I lied to the students. I said, that the derivative of f of x, f prime of x, and I apologize, but I do have to make a living. If I would have taught it my way, I may have been fired. And then you have this very counterintuitive thing. By the way, this was not the original definition. This is due to Cauchy and Rasmussen. Newton had this definition. But for him, h was infinitesimal. It was not a finite quantity. And somebody called Bishop Berkeley had a great laugh at Newton's calculus. He was a bishop and he was trying to talk back to the so-called free thinkers who think that God doesn't exist and all theology is nonsense, only science. So he said the best defense is attack. And he said, if you look at Newton's writing about this vanishing quantities and dividing by vanishing quantity, it's complete nonsense. And it's even more nonsense than anything in the Bible. And he had a point, and this puzzle, and that's why you have this so-called rigorization of calculus that Cauchy and Maxwell and others did. So that was a party line definition. But this is wrong! The limit and h goes to 0 is nonsense! It means that it can go indefinitely close to 0. It means it's a continuum. You can get like here, go. No. The back stops here. Sorry about that. The true definition of the derivative. And this is the pixel size in the big computer in the sky. Because h is so small, you get the same answers no matter what. For example, if you do it, if f of x equals x squared, and if you remember you like 1, you get f prime of x equals 2x. Wrong! The true derivative is 2x plus h, because if you do x plus h squared minus x squared over h, don't take the limit! Limit is a dirty word for me. No limits because it's completely meaningless. Just use the pixel size in the big computer in the sky. And since it's so small, there's no way you can write it down, you leave it as a symbol h. But if not, it's a specific number h is tiny. So, you simplify, you get 2x plus h. This is the two things. Now for practical purposes, since h is so tiny, it's okay to take h equals 0 for applications. But in the true world, the true derivative is this. And using this definition, you have counterparts of all the calculus rules that are much easier to prove, and computers can prove them too, and can program in computer. So you have the product rule, the addition rule is the same. So f of x times g of x prime is not what you think. I think it's this, f of x plus h, g prime of x, plus f prime of x, dx. So this is the true. Of course, since h is so tiny, the pixel size of the big computer in the sky is almost true when you're learning calculus. So you can do everything with like this. And the fundamental theorem of calculus becomes a triviality. What is the integral from a to b? It's f of a plus f of a plus h. It's what's called the Riemann sum, but it is. And the fundamental theorem of calculus becomes a complete triviality.
But the answer to the thing on top, shouldn't it be symmetric in f and g?
No, because the h, no.
But f,
It's almost.
multiplication though is symmetric. F times g is the same as g times h.
Yeah, but you do it. F of x plus h. Do it, exercise for you, homework. F of x you still have the wrong intuition. So, oh, Simon. Yeah, I think that's right. F of x plus h minus f of x. Oh, man. That's right. That's right. Times d of x plus x, right. Yeah, f prime of x times d of x plus that's right.
There was no h in that term.
Yeah. F of x plus x, so it's f of x minus f of x times d of x plus h plus f of x times d of x plus h. I think it's right. Okay, doesn't matter. Nothing has to be good. Yeah, that's right. Okay. So that's the true product rule. And you have the quotient rule, and you have it's a little bit more complicated because of the h. And you can always cheat and use h equals 0. But then everything and then to plot. And Roll's theorem becomes zeros, that's not always, the analog of zeros is where it changes sign. So the function x minus 2 changes sign between 1.4 and 1.5. And then make it 1.41 and 1.42. So you can always find smaller and smaller and smaller intervals where it changes signs. So you can always think, so when you give a calculus, plotting, and with computers, it's very easy, that's fine. All it takes is we change the sign, and then maximum and minimum, well, it's stopping from increasing to increasing. And you can write a computer program that does calculus much more fun and painlessly than what we traditionally teach and torture our students. So this is my way of doing calculus. Let me conclude in the last few minutes of mentioning another paradox with infinity. That people don't think it is a paradox. Claude Gödel allegedly proved that mathematics is incomplete. He constructed a statement that is neither provable, you cannot prove it from axioms, nor unprovable, but is nevertheless true. And nowadays we got used to it, so there's a euphemism for this. It's called undecidable. But I don't like the word undecidable. I still believe that every statement is either true or false or meaningless. And the reason it is meaningless because the notion of provable is flawed. The notion of provable means there exists a proof. It doesn't say how long the proof is. There exists an integer n that have a proof with n lines. And every statement that has there exists an n by the extent of the all infinite range of integers is meaningless because there are only finitely many integers. So this is a priori meaningless, the notion of provable. Provable in 100 lines is meaningful. Provable in 1,000 lines is meaningless. Provable in a Googleplex number of lines is meaningful. But the notion of provable, or for that matter unprovable, is completely meaningless. So no matter Gödel got this, things like this.
What about provable in Z lines?
So what?
Z lines. Z.
Oh yeah, right.
That would seem a natural notion.
Oh, right, make me notion, sure. Yeah, right, then finite, sure. But then everything is decidable. I hope. Now it's true that sometimes we have some statements that have the so-called quantifier. For example, the statement for every n plus 1 square equals n square plus 2n plus 1. A priori, in math philosophy, This is meaningless. Every time you have for every integer, meaning no matter how big, for every third integer, this is meaningful because of only fairly many integers. It also can be made meaningful by saying this is true for symbolic n. When you have a symbol n, this is true. And whenever you have something true for symbolic n, it's true for every integer n, but only fairly many of them. But what Gödel proved was not what he believed, that there exist true statements that are neither provable or unproved nor provable. He proved something else. He proved that there is no infinity, that the whole mainstream mathematics, all set theory and everything based on it, what 95% of my colleagues do is complete rubbish. It may be a nice game, it still makes sense, like chess. He doesn't have any, the king of chess, he's not a real king, he's a game. So it may be a fun game, but they're also liars. When they apply for funding, they claim, aha, it's important for physics, for engineering. Yes and no. It turns out that all the physics and all the mathematics, the engineers and physics need, most of it has been developed by themselves. Whenever they need something, they can handle it themselves, doing it their way. So it's a little bit lying, but don't tell anybody. I told them. But maybe applied mathematics and numerical analysts are honest. They could be used for things. But otherwise, it's just a game that they think is fun, but frankly, I think it's a game, but for me, it's not a fun game. So they can do it as long as they do it in the spare time, as a hobby. Maybe like chess master, the top 10, the top 20 mathematicians should get paid for this. But not the 50,000 members of the Rutgers Astronomical Society who do the same old mainstream stuff, that 95% of it is completely fictional, an artificial game that has nothing to do with reality. So here I conclude. Thank you for your attention.